30 minutes. Who wants to start us off? Yes. 1, 2, 3, 4, 5, 6, 7, 8. Probably not going to get that far. 9. Okay, who's first? Yeah. What page? Page 87 of the practice exam reader, number 8. 87. I'm going to try to go through these as fast as I can, see if I can finish. Number 8, you said? This one right here. That's using a term, this is the KA2 concept, but it's using a term we're not going to see on the exam, which is equivalence point. But it would be that second loss of the proton, so don't worry about that one. Number 2, yes? Page 101, the practice exam reader. 101. You said number 11? Uh-oh. Yeah. What is that thing right there? Anybody? Strong acid. So that, you don't need the Ka. This concentration will equal the H3O plus concentration. Take the negative log of that number. Next. Wait, you were number 3? We'll see how crazy your questions are. You might have to cut one. 79. Just want to make sure I get to everybody, that's why. 79. Number 17, you said? This one? Okay. This is a Hess law problem. What you had to realize is, hey, those two go together, and those two go together. See that? They're likes and likes. So I'm going to go to the back page of the exam, or what in the practice exam reader is right here. I'm going to write down this reaction, ammonia, that one, and write down its K. And then I'm going to write down the other one, was it HF, I think? Yeah. This one, and write down that Ka, and manipulate those two simultaneous equations to add up to the one you saw there. Is that okay? That was fairly fast. Let's see how crazy your second one was. I might have to cut it.
Page 83, number 13.
83. Number what? 19? 15? 13. Oh, a pretty similar question. Anybody, what am I going to do with that sodium? Spectator, drop it, erase it. Cl, same, erase it. NaCl, same, erase it. All spectators. So this is the opposite of the Kw equation. Okay? All right, next was 4, you're 3, 4? I don't know. I didn't even look. Opposite. Wouldn't it be this? Yeah. 4, yes.
Page 59, number 17.
59. 17. This one. Oh, this is a type of KP problem that happens occasionally. So for the ice table, let me talk it out. You're going to ignore this. Okay, solid. You only pay attention to these two. But only solid is introduced. So this will be 0 and 0. Is that okay for initial? So it has to shift to the right. Okay, so plus x. Then, notice you want the total pressure. So when you write the E line of the ice table, let me just show you a random ice table here. Did I draw an ice table? Oh my gosh. No, here's one. It's not this one, but let's say if you're doing something for pressures and you see the word total pressure in there, for all the gases, you need to add up the E line because these are the partial pressures. So the total pressure would be the sum of all the pressures of the gases. In the case of that problem, it's for the products. The gases are all in the products. So you're going to sum the E line under that one and the E line under that one. Those two numbers, that will be your answer for total pressure. Okay, so it's one additional step. That's fairly common for a KP problem. Okay, you were number 4. 5. Yes. Page 96. Page 96, number 93. No. Page 93, number 23. 22. Oh my gosh, you can't hear anything.
What page?
Okay. 93, I think. And I think I'm doing 22. This is the one I was just referring to earlier. Following reaction is exothermic. So this is exothermic. Heat here. Plus heat. That's exothermic. Okay. pH is 7. Yeah, that's the KW equation. It better be 7. It's neutral by itself. It's the reverse of the KW though. Okay, the pH of pure water at 45. The following is exothermic, and for pure water, pH is 7. pH of pure water at this. So I'm increasing the temperature to get to 45. This will shift this reaction, which way, right or left? Anyway. Left. That will make the H, how it's right, written H plus here, H3O plus go up or down? Up, and that'll make the pH go up or down? Down. So expect it to drop below 7, probably B. Okay. You're in pure silence. I assume that means you totally understand. The OH will increase too. Yeah, you're right. I agree. Okay, what's happening here? Why is it okay, everybody, that the pH goes down and the pH goes down? What is changing actually here? The KW is changing. So the KW is not the same value anymore. So both are going down. So the pH scale in this world at 45 degrees C doesn't go up to 14 at maximum pH. It might go up to 13 or something like that. Okay, that's why they both go down. It's not changing the acidity or basicity. Still neutral. It's just dropping the equation. pH plus POH is no longer 14, 13, whatever. Okay? You were 5? 6?
65, number 1.
65. Hey, we're making good progress here. 65. Okay, let's see if I didn't speak too soon. What number?
Page 65, number 1.
Okay, 65, number 1. Here we go. This is what I think you were referring to earlier. Okay. So, first, are they buffers? Yeah, that's a conjugates. D, conjugates. C, yep, conjugates. Yep, and they're all weak. So you can't eliminate any as far as conjugates go, and they're all weak. So they're all fit so far. To buffer a solution, you want the pKa of the buffer to be as close to the pH as possible for the buffer to be most effective. And that way it could best buffer the solution. So what I would do is take the negative log of all these numbers. The pKa that is closest to the pH is going to be your answer. Probably A because of the -3 there.
Thank you so much.
No problem. You are 6? 7? Hi, yes. Sweet. I love it. I like how you all working together here. 8? Yes. Yeah. How that works? Yeah. Question about, let me write this down. Not here. General question. Good one. This is going to be one of the formulas that's given on the exam. This is the Ka for an acid. That's your equilibrium constant. It's a type of concentration K, Kq. This is for a base. But, oh, and this is your Kw. It's a constant at room temperature, 1.0 times constant. I'll give that to you on the exam. Okay. However, oh, wrong color. I wanted a different, noticeable, let's see, different than purple. Okay, that's not helpful. Those two must be conjugates for this to work. So, for example, if you have the Ka of HF, let's just look it up on the table for fun. So this this will be on your exam again. Ka for HF is right here, 6.6 times 10 to the minus 4. So I just looked this up. The Ka for HF equals 6.6 times 10 to the minus 4. That means the Kb for F minus is equal to Kw divided by Ka, if you solve for Ka here. And that's 1.0 times 10 to the minus 14 over 6.6 times 10 to the minus 4. Why would you need to do that if you were solving a pH problem where, let's say I had 1.0 molar sodium fluoride, and I want to know the pH. This is an ice table problem because anybody, what's this? It's a weak base. Because you ignore sodium, it's a conjugate of a strong, it's a spectator ion. Drop that garbage, and so all you're left with is F minus. But if you look in this table here, there is no Kb given for F minus. So you have to find it by yourself. So you find it because that is given in the table, and that's a constant. And then you would set up the ice table per the usual. So you write a base plus water. The base grabs a proton. The water drops a proton. ICE 1.0, ignore 0, 0, minus x, plus x, etc. But this is going to have a Kb associated with it, not a Ka. Is that all right? That's the time that you're going to use this formula most often. Okay? But they must be conjugates for that to work. Next, your 9. 8, 9. Yes? Page 93. 98. 19. Oh my gosh. What number? Wait, I think I heard 93 the second time. And, okay, people in the front were messing with you. You did a perfect job. They were saying 19, but it's page 93. I'm going to guess number 19. This one? Okay. Let's see, determine the pH of a solution with initial concentration. Okay, anybody, what's that thing? Strong. And this thing? Weak. So, the strong, the pH, if you only had this, you would solve it. Ice table, yes or no? No. But this one, yes. What are you going to do? They're solved completely differently. I am going to ignore the weak because it contributes nothing. It's weak. So just pay attention to the strong one if you have a mixture of strong and weak. So you're going to pretend the weak one is not there and take the negative log of that number. I bet it's probably 0. But you can use a calculator and double check. Okay? I'm totally ignoring that. Yep, definitely. Notice also the concentration of this is much, much smaller, so it even more so is contributing less. The lower the concentration, the less it'll contribute. See how we're doing on time? I could actually do a couple more questions. Anybody else? 1, 2, okay, not a lot more. 3, maybe 4. Okay, 1.
65, number 2.
65. 65, number 2.
Similar thing, but in this case it does make the pH a weak and a strong, because they're the same level.
This is, okay, the other one, why is this different is the question. The other one, they were both together. This is starting with one and then adding another. Would do what? So, do you see the difference? Those two, they were both together. What's the pH? This is, I'm starting with the one on the left, acetic acid. I add HCl, it probably drops the pH. Okay, cool. 2. 2, oh, I thought you were canceling out. Yes?
Page 101, problem 15.
101. This has a couple parts. No, oh, okay. It's just on 2 pages here. So I've got this reaction here. I think I have to write it down. Let's get my slides back here. Okay, because the question's on the next page. 3A solid plus 5B gas goes to 5C gas plus 6D solid. All right, next page. Okay, which one do you want to do, or several, or?
The last two.
Last 2? Increase the pressure, same as decrease the volume. Look at the gases. 5 and 5, no change. No change as far as shift goes. So B should be no change. Is that okay? All right. Heat. Delta H was 0, so there's no heat. So I presume there's no change again, because delta H was 0. Is that okay? There's nowhere to shift it. There's no heat to speak of. Let's see, that was 15. Yep. Oh, no change. They were all no change. That was really funny. Okay. I think of funny stuff like that every once in a while. Okay, cool. You were 2, 3. 3 passes. That's fine. Oh, there you are. Yes.
Page 79, number 13.
79. 13. Okay, we don't need that anymore. Okay, okay, this one, anybody, what would we call the combination of these two? A buffer, yeah. Base and its conjugate acid. They're both weak. They have similar molarities. That's a buffer. What you haven't learned yet, that in my class at least, that we're going to learn next time, there's 2 ways to solve this. The hard way is the ice table, which you're free to do that. That's fine. I'm not. I'm going to do it the easy way. There's an equation, which is a what do you call those things when you like cheat? A hack. It's a hack. It's a hack of the ice table. It's called the Henderson-Hasselbalch hack. Okay. So what you would do is say pH. I will give this to you on the exam. You need to find the pKa for this one is going to be the negative log of this, negative log of this number right here. Okay. The log of the base, that's going to be 0.1 up here. And then the acid on the bottom, the conjugate acid specifically, 0.25. That's it. Okay? This is a short version or a hack of the ice table. Okay, you're 3, 4. Yeah. Page 83. Page 83, number 6. You can ask me afterwards. We're not going to quite get to indicator, so I won't put that on the exam. It'll make people mad if I cover it now, but I'm happy to answer it privately. Okay? So check with me later, or ask for the final, whichever your preference is. All right. How are we doing? Okay? We survived?